Okay, we're going to learn how to divide polynomials today. So look at this question. You remember this kind of stuff from junior high? Did you do long division with numbers? You remember that? And you were like, how many times does this go into this? And then what's the remainder? Carry on. How many times does it go into that? Carry on. Okay, I'm going to skip doing that. I obviously could do it for you, but we're going to go to a shortcut method. So just like long division with numbers, we can do long division also like this with polynomials. So if I'm going to do this polynomial divided by that one, I could do a long division. Okay, but I'm going to show you a shortcut. All right, so here's the shortcut. It's called synthetic division. So I need you to draw me a box like that. Okay, we're going to put the polynomial here at the top, but here's the trick. Your polynomials have to be written in decreasing order. So there's x fourth, x squared, x, and then a number. There's something wrong with this as an order. Can anybody pick out what the situation would be wrong about going down, 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 down? Can you identify any problem with going down one, down one, down one, down one? The problem is in that zone. What's going on? No. We went from an x fourth to a x squared. Did that go down one? What happened? We missed x cubed, right? Okay, so we're gonna kind of think that's in there. So we're just gonna call it 0x cubed. Okay, so here I go. 1 for x fourth, 0 x cubes, negative 3 x squareds, negative 15 x's, and then negative 8 because they have x to a 0 technically, right? So these are polynomial coefficients and they have to go in order. Okay? So sometimes you're going to have to do fillers. If there's an order missing, you have to fill it in. Okay, and then outside, you're going to put the root number. So if it's going to be divided by this factor, this is a factor, what is the root number? What is the x-intercept on that factor? Positive 3. Okay, if this is a factor, what's the x-intercept? 3. Okay, ready? Here we go. Bring that number down. Times, so 3 times 1 is 3. Add, so you get 3. And then repeat. Here we go. 3 times 3 is 9. Go down, adding, add is 6. Times diagonal here, so 3 times 6 is 18. Add vertical is 3. Times diagonal, so 3 times 3 is 9. Add is 1. Okay, so writing a division statement. So we started with this polynomial. And we divided by that polynomial. And we got a quotient. So sometimes I say write a division statement, which is the whole thing. This divided by this equals this. And if I say write the quotient, you would just write the answer. So this is the quotient. Okay, here's a question for you. If you have any x fourth and you divide it by a single x, what does the result become? An x fourth divided by an x will become a, any x fourth divided by an x would be a x cubed. Okay, so this is going to be a cubic. So this is x cubes. What do you think this is going to be? X squareds, x's, the next in order is just the number, and then this is a remainder. Okay, so this is how you write it. And then the remainder looks like this, 1 over the factor, like that. Okay, so here we go. Let's try another one. Here's my box. So look at the polynomial quickly. Are there any gaps, or does it go down in order perfectly? Cubed, squared, x number. I think that's good, right? There's no gaps. So 3, -2, -10, -120. In front, I'm going to put the x-intercept or the root number. So what's the root number to this factor? +4. Okay, process starts bringing down the first. Times diagonal, 12. Add vertical, 10. Times diagonal is 40. Add vertical is 30. Times diagonal is 120. Add 0. Okay, so it says write a division statement. So this polynomial divided by this polynomial equals. Okay, so look at the top here. We had a cubic divided by an x. So what is any kind of cubic divided by an x going to result in? X squared. So this is going to be a squared. So 3x squared, and then plus 10x plus 30, and there's no remainder, so then it's perfectly divisible by it. That's what this means. Okay, we're going to find out as well that because this was perfectly divided by, we can now tell you that 4 is an exact x-intercept on this graph because there was no remainder. Okay, last one of these. Okay, check out your polynomial. Does it go down, 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 down perfectly? x4, x cubed, x number. Does it go down perfectly? Ben says no because we are missing an x squared. So we're going to go 4, 5, 0. 4, 5, 0, and then the -10, -60. And we're going to place what root number, what x-intercept number on the outside? -3. Okay, bring the first down. Okay, go ahead. Times, add, times, add. Okay, this time my question said, tell me the quotient. So the quotient is what you got after you divided. So I need to write this. So this was a fourth divided by an x. So then this would be a cubic. So 4x cubed minus 7x squared and then the remainder, you have to write it as a fraction. Do you get the fraction part of it? For instance, this is like a quick example here. 9 divided by 2, obviously you should know that that doesn't work perfectly. I can do that 4 times, and 4 2s is 8, so I have a remainder of 1. 1 out of the divider, 1 out of the 2, right? 4.5. Does that make sense? Because this is the remainder, and then it's out of the 2. Okay, so a couple things on what to do. Okay, so this remainder thing is important because if the remainder is 0, it's perfectly divisible. That means those are x-intercepts. If you don't have a remainder that's 0, then you can't say it's an x-intercept, it's not divisible. Okay, so here is a thing called the remainder theorem, and this is a shortcut to tell us if it is or not. So we did this question already with synthetic division, and now we're going to try it a different way. We're going to see, is this divisible or not? So what you're going to do is you're going to test the root number. What is the root number? The root number is positive 3. So we're going to plug a positive 3 into that. Calculator typing, and I get 1. So this is a remainder of 1. So what do I know? I know that x minus 3 is not a factor. And I know that positive 3 is not a x-intercept. That's what it tells me, because there was a remainder. Okay, next one. So you have to think about, well, what is the root number? You're always doing the root number. So 4, positive 4. So you're going to plug in the positive 4. Okay. Typing, typing, typing. And see what you get. Okay, 0. There's no remainder. So what do I conclude? I can now tell you that x minus 4 is a factor. And I can also tell you that positive 4, the number, is an x-intercept. Those things are true because there was no remainder, okay? So do you notice how this number and this number matched what? Look it back. This is the one we just did. Look at the remainder on our synthetic. 0. And then look at this first one. This is the same question we just did. Look at the remainder. It was 1 there. So your synthetic division and your remainder theorem will work. Okay, I'm going to skip the last one, but just pay attention because this one you would be plugging in a negative 3. Okay, you would have to plug in a negative 3. So I just make sure you're being careful on your calculator, right? Use your brackets. Okay, that's all. I just want to tell you to make sure you're being careful in your calculator, okay? Negative numbers, that can mess people up if they're not typing it in. Okay. Factor this thing fully. Okay, so here's the deal. I don't know anything about this right now. So I'm going to figure out what are some factors of this. So I'm going to test. I'm going to test some root numbers. What's the easiest number to try? Let's try 1. So what is 1 cubed minus 3 times 1 squared plus 4? What does it equal? Did you get 2? So guess what? Done. It didn't work. It had a remainder. This is a remainder. So I'm going to test negative 1. So what is negative 1 cubed minus 3 times negative 1 plus 4? This time I got 0. So that's good. So what do I know? I know that negative 1 is an x-intercept then. What else do I know? X plus 1 is a factor. Okay, because I tested it, no remainder, that's what I know. Okay, so we're going to do some synthetic division. Okay, tell me the order. Does it go boom, 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 decreasing, or is there any gaps? There's a gap. Right there, there's no x's at all. So 1 cubic, negative 3 squareds, 0 x's, and 4. And what is the root number that I'm going to put on the outside? I'm going to put a -1 on the outside. We already know that this should be 0 because we tested it with a little bit of a shortcut. Okay, so here we go. Let's show that it is 0. So there's a 1 times add times 4 add down times -4 add down 0, which is what we knew. We already had shown that that was going to be 0. Okay, so what is this here? Remember what we were doing? We were doing this as a cubic, divide it by an x, so this is a squared. Okay, so here we go. F of x equals. Okay, so here's what we were doing. This divided by x plus 1 equals this. Therefore, this times x plus 1 equals that. I don't know. Does that make sense how I said it? If you do something like 24 divided by 3 equals 8, you can also go back and say 8 times 3 equals 24, right? Does that make sense of how I did it? So this divided by that is that, therefore this times that is that. Okay, factor fully. Is there some more we can do with that? So this is a simple trinomial. What multiplies to 4 and can get you an add of -4? So this is your answer. Do you notice how I also had equals f of x? So that's important because it's an equation. If you also wanted to, you could do this as an x minus 2 squared if you wanted to as well. But this is okay and this is okay. So both of these would work. Okay, quickly, I didn't ask for this, but we're going to graph it so then I don't have to do another question. Okay, graphing. Let's go back to the original. What do you know about this x cubed? What would it look like? What letter? An n? And do you know what the y-intercept is already? If you look at the original, what's the y-intercept? That quickly. The y-intercept is 4. You can just look there. Obviously, you could plug in here, but that would take more work. Okay, so what are we doing here? We're going to go x-intercept at -1. We're going to do an x-intercept of 2, and we're going to bounce off of that one, right? So we need to make an n with a bounce. So some questions might say factor fully, which stop there, and then this one you might have to do all things and graph things. Okay, I need 5 more minutes and then I'm done. Okay, so we're going to skip one question because we just kind of covered it. Okay, working backwards. So here's a polynomial divided and the remainder was that. So this time I don't know something in the polynomial. Okay, so I'm going to show you 2 methods. You can use the remainder theorem method or you can do the synthetic division method and you can pick which one you like better. Okay, so first things first, what is the root number there? -2. Okay, so synthetic or remainder theorem says I should plug in a -2. So 2 times -2 cubed plus 3 times -2 squared minus k times -2 minus 5. So when you plug that in for x, you're supposed to get -17. Okay, let's see what we can do without our calculator. Ready? -2 cubed. Anybody know that one? -8 times 2, so that's -16. -2 squared is +4, so +12. So this is going to be a variable, but I'm going to do a plus. Are you okay? Because there's a subtract and a negative. So plus 2k. Okay, give me all three of those together. Okay, so -16 plus 12 is -4, minus 5 more, we're at -9. Add 9 is what, -8? Yeah, did I make a mistake? Oh, yeah, I copied it down wrong. So then I gotta go back there. Thanks. And I gotta go back there and there. Is that, and am I good now if I just change all that? So k equals 4. Okay. I find most people pick synthetic division just because it's maybe a little bit more fun. Okay, I'm going to go down the order. Am I good? Cube, squared, x number. That's good, right? So 2, 3, k, -5. And I'm going to put the root number on the outside. Okay, we're going to start synthetic division. So give me a pull down 2 times -4, add down -1, times and get to 2, stop. You can't do anymore. Okay, now the remainder was -17, so where could I put that? I could start back here. Okay, what would I need to have in this position? -5 plus what is -17? -12? Okay, what would I need in this position? Because this times this would get me to -12. -2 times 6 gets you to that. Now, what plus 2 is 6? And there you go, 4. We got to the same answer. All right, last question of the day. Some kind of polynomial, I don't know this polynomial, some kind of polynomial at the top here, is divided by, so give me a root number in the front, and this is the results. So I'm going to be putting the results at the bottom. The result would go at the bottom, right? Okay, so check out the order. Would this go in perfect order? This is a squared, this is an x, and this is a remainder. Is there anything missing? The number. There's no number. So x squared, x, number, and then remainder. So we need a 1x squared minus 2x, a 0, and a 4, like that. Okay, can you kind of work this backwards? It's a little bit of working backwards. So what would I have needed to bring down to make a 1 there? You would need a 1. So 3 times 1 would have put a 3 there. What plus 3 is -2? -5, is that what you said quietly under your breath? Okay. 3 times -2 would have put a -6 right there. What plus -6 is 0? +6. And then what are we doing here? 3 times 0 would have been 0 there. And then what would I needed at the top? 4. So this is my polynomial, and it says to write it as a g of x. So you're going to have to go g of x equals, what is this original? Because I had an original and I divided it by an x and it turned into an x squared. So what was my original degree? X cubed. So 1x cubed minus 5x squared plus 6x plus 4. There you go.